Okay. Hi, everyone. I'm happy to present you a project I'm working on actually. So it's a development of a programming language, superset of R, and you will see what I am talking about when I present type R. So to begin, we'll just start with an introduction, and I like to start with the logo. So I decided to create also logo at some point because for me this language sounds really interesting, and yeah, I can give you the story about how we found the name type R. But yes, that's the logo we have, T for type, and it's just inspired from the original logo of R. So what is type R? So type R is R with type. So we'll see why, because types nowadays are really important to build stuff and build them efficiently. It's also R with cool syntax. So yes, same syntax, but we add something really interesting in them. And also R for productivity. So when we build something with R, I know that that's the philosophy. R is really yeah, it's free. It's easy to manage things and also to produce interesting piece of work because it's really there to do prototypes and make interesting things. So also we have R for data science and machine learning. So that was also another goal I give myself. It's to bring many interesting things for R because we know that R is mainly for statistics, but we discovered that it has also really, really good features to build machine learning packages, and I wanted to improve that with type R. And also R for package management and development because we know that packages are important and sometimes it's hard to maintain them because of the type system. And also R with love because we love R. So to explain why we need types, we will talk about dynamic versus statically typed language. So don't pay attention to the strong and hidden. So it's come from an interesting sites that help us to learn programming language. So dynamically typed language are different from statically typed language for some reason. To give an example, we'll see an R code because R is a dynamic language. That just means that we're able to do whatever we want with the values of our variable on our functions. For instance, I can create a variable A with a value 10, that's a number, but at any moment, at any point of my code, I can just change its value or the type of its value. So I put a true, that's a Boolean. So I now hold logical values. And that's also the same with the functions. So I can read a function that I call add and put two parameters A and B that I will add together. So what we expect is that adding number will work, but the problem also is what happens when we put values that aren't expected. R don't have a direct way to manage that. So because of that, we can have some problem because yeah, there it's really obvious what's wrong. But when we're working with a large code base, this kind of error or bugs can come really easily. That's why we have also static types. We have more guardrails to be more certain about things. For instance, a variable will hold its types. So if we put an integer, for instance, we need to explicitly put that it's an integer, and we can't change the kind of type it holds. So yes, every language has types, but each language has its own way to manage types. And also, when we do that with an addition in Java, we see that we can specify what are the type we want and what is the type we need at the end of a function. So with that, we have a way to manage at the beginning, before pushing the code to production, how to hold it. For instance, if I give an example, so it's an example in Rust, but you will understand what it is. If I put number A in there, yes, I think I understand why it's working like that. Cargo new app. Cargo new app. C'est des app and uh, and cargo that main. So yes, I will do the same. Let A and that's a mute. In Rust, we need a mut A equal 10. If I change its value, for instance, A equal true, in this case, we'll see that my editor is now able to prevent me saying, hey, there is something wrong there. So that's the goal of a really good type system. It's to prevent some kind of error way before we push code into the production. So it can be before you publish your packages because they can be full of bugs, but most of the bugs can be caught really early. That's why we have different properties for dynamic and static typing. For instance, we have conciseness. So dynamic programming language like R, since we don't need to put types and manage types, it's really concise because we don't need to write any type at all. For static typing, that's not that simple because we need to put type before and at each moment. There are a few restrictions with dynamic typing because now we can do whatever we want. So we can put everything we want in any function or in any variable. But in static programming, we have a lot of restriction. So for instances, that's something that can be weird, but in language like C#, you can add an integer to a float because those are two different types. So you need to convert them explicitly. So for that, it's a bit annoying to work with that. But the advantages with static typing is that the reasoning is made easier because now you can build your own type. You can manage how a function or a variable will behave. You have also advantages is maintainability because now the code is more readable and you can catch bug easily. So it's really great to develop a package with this kind of thing. That's why we have also a new improvement. It's type inferences. I have shown you a Rust example, but Rust is statically typed language. But if you see this code, you will see that at no, I didn't put any type in there. So I use also closure, some kind of function. I create a variable, but you see I didn't put any type. So it's still statically typed, but we don't need to put the type there. So with this kind of type inference, now the language has the intelligence to know what we're talking about. And you just need to use type when it's needed. So that's a good improvement. That's why I bring it to that, because now we have a switch of dynamically type programming language like JavaScript that goes to TypeScript, Python that goes to Mojo Lua, that goes to Nelua, with a switch to statically typed programming language. So like that, we can have both of the best of both worlds in some sense. What about R? So in R, we have seen some really good improvement. For instance, someone that presented it a few moments ago, I think like last year, December last year, I'm not sure. It presented Vapor. So that's also a super set of R that's really meant to do the same result as myself when I work with type R. Yeah, you should also check his work. It's really good. We also have TypeRacer, that's a package that were built by Turcotte and his team. So that's a R package that help us put some restriction to function so we know what we put in there. And there is also my work, TypR, that I will present now. So I have two objectives or two goals with TypR. It's to do it for data science and for package management. Data science, you know, like machine learning and everything like that. I think R has really a potential to do that, and I wanted to push it further also for package management. So data science made easy with type R. We know from R that everything is a vector. That's a vectorization concept. But we also know that for some kind of task, we need to use scalar values. And we also have the concept of broadcasting. Broadcasting that's also used in other language that use multidimensional array or tensor like NumPy, TensorFlow, PyTorch, and everything like that. I wanted to see if a type system could do that. So spoiler alert, it's really complicated to do that. But I have found something really interesting to do so. So now it's a type R code. We'll see what we can define. We'll start with a second line because it's easier to read. So in type R, now the variable declaration must be preset by a let because we can declare a variable and later change its value. That's how programming language do nowadays. But like I said before, now that we have possibility of the language is smart enough to infer types, you don't need to put any types. But if you really want to, you can put colon and specify the type. But normally, TypR is able to understand how it works. Same for what we have with arrays. So we have arrays. The type is this strange things. So let me just explain. It's just say that it's an array of three elements of a certain type. So that's three elements of type int. So each array must have each member with the same type. To present an example, yeah, that's a Rust code. Um, I can do that. Let a equal, for instance, 8. And if I want to see the type of A, so I need to put it like that, an expression. You see that type R, yeah, for instance, it's just a prototype actually. It can see the type of element and the value it holds. So if I put now an array, for instance, 3, 5, type R will be able to know that's an array of size 2 on type int. I can also do the same, for instance, with Boolean. So in type R, Boolean are small caps later. True. And so we have something like that. Can also add something else like that to work with. A cool stuff about arrays that you can define them recursively. It means I can do that like Python or Julia. I can put arrays in arrays and the type will be inferred to. We know that it's an array of 3 elements, 1, 2, 3, of array of 2 elements. So we have also security because now we can only build things that are like rectangle hyper rectangle. For instance, if I take this code and put it that way, well, I guess I've taken too much. And I show M1, we'll see that it's able to know what it is, and we're able to build that in R. Because I haven't said that, but it generates R code. So I can see that. So that's a specific way to create an array, because we see that type R arrays are arrays. So don't pay attention to that. That's just a helper function that were built there for some utilities. But you see that now we're able to do that. We can also build something greater than that. For instance, multi-dimension. So I can build something of dimension 3, an array of 2 elements, of an array of 2 elements, of array of 2 elements of type int. So I can syntactically build that, but I don't recommend that because it's a bit complicated to do that. It's possible, but I think we can use other combination to do that. So that's what I like about R arrays and TypR arrays, because they act like tensor, like TensorFlow, PyTorch, and everything like that. So I have made some discovery about linear algebra we learned at school. So now we have the possibility to type that. We can also see that matrices are just to the array, and vector are a specific type of matrices. So it goes against the normal protocol of R, but this representation looks more logical in this way, but you can still call arrays, vector, what you want. So you don't need to understand everything in this code because it's not that simple. But just know that we can use our own shortcut, like with math or matrices. I can use the name I want and with parameters, and I can say which type its target. So it's like a replacement, but you will see that we are able to build two specific functions with matrices. The transpose function that help us rotate a matrix. So I can say that we take a matrix of shape m line n column, and we can find a matrix of n line m column. So the switch can be made. So now we're able to do that kind of things. We also are able to do matrix products. For instance, we have a matrix MP on a matrix Pn, and we can obtain that. So now it's type checkable, and also it's inferable. So if I take something like that and I do a transpose, TypR will be smart enough to know which size it is. So we can now do some operation and know where it works and don't works. For instance, this operation between two matrices, I can do that with M1, M2, and do the dot product I defined before. So the first one work, but the second one don't work. So the editor will be able to know that and say, no, it don't work. So that's the advantages when you want to build some data science library, for instance. I have also a bonus. If you use specific keywords as variable name, for instance, at, you will be able to use specific operators. For instance, the at function will help us build at operators, and you can use that as operators. So the dot products can be used in this way. I can also show an example with add this time. So just add two matrix. So you don't need to understand everything in there. And when I add everything, when I use the add keyword, I can use now the add operator. So that's called operator overloading. That means you can now build your own types. For instance, you want to build a specific kind of data frame. Now you can use those operators with you. And we have a reserved keyword to use that. For instance, minus for the minus operators, mul for the multiplication operator, etc., etc. So that's operator overloading. We can also, another discovery I've made, as I said, we can represent vector like a matrix. So we can have a column vector, so a matrix with just one column, and a line vector, a matrix with one line. And so the operation we know from matrices, for instance, transpose, will help us transform a column matrix to a row matrix, etc., etc. So that's really interesting to see that in this way. So that was one of the most interesting discovery I've made with this type of representation. For instance, I have made V1 dot V2, and I can build a new matrix according to those two. And I can also do a scalar product with a dot product. Now, I know that we work with data frames also. So I have made something interesting, and with the help of my brother, I decided to put it into work. So there is a way to define a data frame. I define it as an array of records. So we can say that's an array of objects or an array of lists. And so I can build an array like that with fields name and age. Name, that's a character, and age, that's a number. And with that, I can build now a specific function. The function name is just hasMinor. And I can target a specific column. If I do data frame, because I made a shortcut there, if I made a data frame with record age int, it just means that it target every data frame that have the column age of type int. So with that, we're able to work with specific data frames in a certain way. How can I say that? Yes, with data frame that has a column age of type int. So if you have a data frame, any data frame you want, if it has this column, it will be accepted in this function. So you are now able to build functions that are specific to a specific set of columns. So if you want to build packages about columns indicating genders, for instance, now you have the possibility to use that. So because I know that our user and data scientists or data analysts use quite a lot data frames. So building those kind of packages could be very interesting. Now we go to the package section. So it's a bit more like a dev section, but I decided to make it really simple and don't go to every details. But if you want more, you can still go to my GitHub repository. So with TypR, and I have a great documentation. My brother made it also that explain some features in there. We also have um, two specific videos that relate also the construction of TypR. Yeah, I think internet is a bit slow. We have type bursts, but not TypR. That's interesting. Okay. We continue until it appears. So for what we've seen until now, we have already seen the operator overloading, and the concept of row polymorphism is what we have done with data frame. So those are barbaric words, so you don't really need to learn them. Just retain the cool stuff, okay? So now we also have a possibility to work with modules. We have uniform function call, interface inference, type embedding, and type import. So all those things are there to make things easier. The names are not easy, the concepts are not easy, but it makes things easier. Because it will help us manage our packages using two programming paradigm. That's object-oriented programming and functional programming. You can use both in R. Because we know that R by default, given its syntax, is more functional, but we can implement also object-oriented programming. Um, because we have different ways to use object-oriented programming in R, like RC, S3 with single dispatch, S4 with multiple dispatch, R6, that looks like more a standard OP. TypR will just uniformize everything, and yeah, it will be based more in S3, but you will see that it's more easier because it's an OP that looks like more how we build our modules or our packages, but still got his functional and object-oriented style. We can also see a bit of what composes the type system. For instance, primitive types. I've made a distinction between integer and number. So that's integer numeric. We also have something like Boolean for logical and character also there. We also have some structural elements. For instance, we can build things with arrays, records, tuples, tag, union, interfaces, and function. So functions are also types. Just to know that, yeah, all those things looks complicated. That can be a bit much, but everything we'll see. How can I say that? It's logical. It's like yeah, it's like things that go naturally together. So with one logic, you can read everything. Also for the OP guy who wants to use some kind of OP in TypR, just think that classes are types, methods are just functions. Inheritance can be replaced by an enhanced composition. And also we can import some OP concepts like solid principle, clean code. I think you heard about this book, design pattern, etc. We have also other functionality for functional programming, like immutability, higher order function, pattern matching, algebraic data types. All those things are there built in TypR and help us build really interesting stuff. So to conclude, what I want to do in the future is to enhance the compatibility with existing R projects using a system of either files that's like the same kind of systems TypeScript use with JavaScript. We also have to improve the performances, so to make the code more performant, since we build our code from TypR code, we can also do some in the middle, on the fly improvements, and also make more interesting syntax, but those syntax are just meta programming. You will see that for what we have in TypR, we have a core language and with a lot of syntax trigger for doing to do the meta programming stuff. And we will see that an example, for instance, yeah, there, like this image show, we will just bring an IST and use some meta programming to have a core or base TypR. So with that, we will do some type checking on transpilation. And for the syntax, that's all. We also have the tooling, where I want to bring some LSP, some AI companion, and everything like that. So people will be able to use it better. So thank you. I am at the end of the presentation. If you have some question, I can still answer because yeah, TypR is a big project and I didn't talk about everything, but I hope what I presented looks meaningful to you. As I said, now I think we should have a playlist. I've made a playlist about TypR and it's oh, yes, there. Mm, ah. I have no internet. Interesting. Yes, so two main video I talk about TypR, but also video because I post it in a programming tier list I have made for this year. So yes, you can find those information there. Okay. Do you have any question? Yes.
Yeah, thank you for the presentation. It's really interesting.
Uh-huh.
I have just a question about the type of the matrices,
Uh-huh.
the type of the data frames, and built in, or should we, as you said, just write type data frame and create it ourselves?
Yes, that's a good question because as you can see, I've made really some atomic building blocks. So that means everyone can build a data frame or a matrix from the scratch, but I want to have a standard library that will hold everything that everyone use because we don't have to build the same things again and again. So I will have a standard library, but anyone can build them that way. And also, that's another topic, but it's about structural and nominal typing. But yeah, even if you build it your way, if it has the same structure, you can still use the function in the standard library. So that's why.
Perfect, thank you.
Okay. So I think there is no more question. Okay, I will end there.